Something that can make or break you on the AP exam is the net ionic equations. This is one question that's got 3 parts. Each part is worth 5 points, and it's an easy 15 points if you know what you're doing. Writing a net ionic equation is taking a molecular equation, taking out all the spectator ions, meaning something that is soluble on both sides, and showing only the reaction that is occurring. On the net ionic equation portion of the AP exam, there is always a reaction. And the way that the points break down is you get 1 point for reactants, you get 2 points for the correct products, and you get 1 point if your equation is balanced. After you have an equation, you have one question that's an all or nothing question. And it's usually about whatever reaction occurred. So let's talk about the strategy you're going to use to tackle this FRQ. If I can get it to load. So this is not my strategy. I have to give credit where credit's due. This came from NIMSI, National Math and Science Institute. The way that we're going to tackle net ionic equations is anywhere we see the word nitrate, we're going to scratch out, because nitrate is always soluble. And so we are never going to see it in a product. We're also going to circle any word that states something about a state of matter other than aqueous. So solid or gas, we're going to circle. Now there's a lot of different words for solid. If it describes its texture, typically it's a solid. So powder, turnings, chunks. If it describes mossy, like these, there's a whole bunch you can get. Gases, they'll either say gas or they'll say vapor. You're going to cross out any group 1 metal unless it is circled because it's a solid or gas. We're going to underline any halogens. And you're going to ask yourself, is there silver, mercury, or lead anywhere in this equation? Does it say anything about silver, mercury, or lead? If it does, you're going to leave it alone. But if it doesn't, you can cross through it. Anytime you see the word burned in air or combines with oxygen, that means it's a combustion. And combustion reactions are very, very easy. So you're going to do a little dance in your seat. Don't get thrown out of the exam. But that means free points. And anywhere you see the word concentrated, we're going to circle concentrated or put a box around it, because we're going to be talking about complex ions. And that confuses some people, but it is very easy as well, and we'll talk about that in just a few minutes when we see one. So let's not waste time. Let's go through a couple of these. I'm going to do one where you do at least one of each of these rules. So this worksheet is in your packet. I'm going to jump around a lot, but I'll at least let you know what letter I'm on. So I'm going to start with Q. A solution of copper 2 chloride is added to a solution of sodium sulfide. And rather than take the time to write out all of that and figure out what's soluble, we're going to tackle this one rule at a time, or one step of our strategy at a time. So we're going to first say nitrate. Do I see the word nitrate? No, no nitrate. I can't cross that out. All right, group 1 matter, circle anything that starts with a state of matter other than aqueous. Solution, solution. Nope, okay. Scratch out any group 1 metal. Well, there's nothing saying that's a solid, so I can scratch out sodium. Sodium's not going to be my answer. Underline any halide. Chloride is a halide. And ask yourself, is silver, mercury, or lead even mentioned in this? Nope, no silver, mercury, or lead, so I can cross out that too. Look for the word combustion or combined with air. Nope. Look for excess concentrated. Nope. How about, I feel like I'm missing something. No, I'm not. All right, and now we're going to write down whatever's left. I've got copper 2 is added to a solution of sulfide. What are these two going to make? Well, that's pretty easy. I'm just going to mush them together. So I make copper sulfide. Now my equation has to be balanced, both by mass and by charge. So by mass means 1 copper, 1 copper, 1 sulfur, 1 sulfur. I'm balanced by mass. But my charge also has to balance, which means these charges at the top have to equal out. So on this side I've got no charges. On this side I've got 2 minus 2. So 2 minus 2 is 0, so that balances out. So this is balanced. I've got an equation, and it says name the spectator ions in this reaction. Please, oh please, oh please, do not write that. That's not going to get you points because it specifically says ions. Read the question, guys. What does it say? It says ions. Ions have charges. So you'd have to say sodium and chloride, Cl minus. Or you could have just gotten lazy and just read whatever you scratched out. That would be chloride and sodium. So let's see how I did. Let's earn myself some points. Let's see. I get 1 point if my products, if my reactants are correct. So this would be 1 point here. I get 2 points for my products, which means if I have 2 products, each one's 1 point. If I have 3, it usually is 1 point for the first, 2 points if you have the other 2. Since I only have 1, this one's worth 2 points, so that was an easy freebie point right there. And am I balanced? Yeah, I am. So I get another point. And I named the correct spectator ions. I didn't fall for the trap of saying chlorine and sodium. So this, I got 5 points. Average on these are usually usually around the 7-ish range. So I am well on my way to my 5 of getting out of here and getting my $100. All right, I'm going to skip around a little. If you're playing along at home, I'd suggest you skip down to S and do S by yourself. But we're going to skip over that because I got a limited amount of time. I got only enough for your attention to keep going for a little while. So we're going to skip to Z. Aluminum metal is added to a solution of copper chloride. So aluminum metal, that's a solid, so I can't do anything with that. Oh, I skipped over. Step 1, look for nitrate. No nitrate. Step 2, circle any state of matter. Metal means that's a solid. All right, underline any halide and ask yourself, is silver, mercury, or lead present? No silver, no mercury, no lead. So I'm going to scratch through that too. So no chloride in my answer. Combined in air, or combusted, or undergoes combustion, or combines with air. No, can't do that. No excess concentrated, so I can skip that. So all I'm left with is aluminum, the metal, and copper, the ion. Now don't get confused. What could happen here? What's going to happen in reality? What would happen if you had left it as a whole molecular equation? You would have something like this. Think back to baby chem. What would happen? What happens when you have a metal and a solution? We've done this lab before. That's right. They switch partners. Aluminum's going to come in here and sweep chlorine off her feet and kick poor old copper out. So what happens? That means that aluminum becomes an ion, and copper actually solidifies out, becomes a solid. So now I've got to make sure this is all balanced out, because if it's not, I'm not going to get that extra point. So I have aluminum, one aluminum, one aluminum, one copper, one copper. And some of you might go, up, it's balanced, I'm done. And you would lose your balancing point because the charges have to balance. I have a 2 plus on this side. I only have a 1 plus on that side, so I need 2 here. Oh, see, look, I'm rushing myself, so I made a mistake. Aluminum is 3 plus. What's wrong with me? Okay, let's try that again. I have to balance out these charges in order to get my balancing point. So 2 and 3, what do they have in common? 6. So 3 times 2 is 6. 2 times 3 is 6. So now my charges are balanced out, but now my mass is all crazy. So I need to put a 2 here, and I need to put a 2 here and 3 there. Yeah, pretend that's a 3. Whew. Making silly mistakes. All right, list 2 observations that indicate a reaction has occurred. Well, copper is blue in solution, and if it's going to become solid, I know aluminum's clear in solution. So first off, this is going to go from blue to clear. Solution will, running out of room. Oh, what else might happen? How about the aluminum will look like it rusts. Let's say rusted, so don't look particularly special. What else might happen? There's probably going to be some change in temperature. You might not get away with that, but if you're in doubt, anytime you have a chemical reaction, there is some change in temperature. And if you really wanted to, you could guess. I would suggest against guessing. Saying change in temperature might get you points, but it might not. So don't shoot yourself in the foot. Know when to shut up. And if you don't know, don't specify. Say change in temperature and see if you can throw a wide net and catch a couple fish. If you can think of some other observations, you may be right. Those would be the big 3 I would be looking for personally. So that's what I would do. I'm going to skip around again to G. Carbon disulfide vapor is burned in excess oxygen. So first off, cross out the word nitrate. No nitrate. Cross out any, circle any state of matter. Vapor is a state of matter. Cross out any group 1 metal if it's not a solid or a gas. So I got no group 1 metal, so I can't do anything there. Underline any halides. I got no halides. Look for the words burned in air or combined with oxygen. Holy mackerel. I see burned in air. Oh, I see burned in air. Ah! Yes! Fire! Yes! That means good things. Good things. Burned in air. Great. Awesome. I have a combustion reaction. So that automatically means one of my reactants is going to be oxygen. But then, there's my oxygen. I don't see any excess concentrated, so I don't have to worry about any kind of complex ions. These things don't usually overlap. So I'm done. I've got to pull down what's left. I have carbon disulfide gas. If you'd like to, you can put states of matter if you are positive of them. If you are 100% positive, that is a gas. I am, because it says vapor. You're not required to put states of matter. So again, know when to shut up. Don't shoot yourself in the foot by putting a state of matter and being wrong. So that's the worst thing that can happen. Don't lose points for no reason. So anyways, carbon disulfide gas is going to combine with oxygen. Now, what I'm about to show you is not chemically sound. And you should never put it as a free response answer as to why this is a product. But this is how it usually works out. When you have a combustion reaction, you remember the distributive property from algebra? Well, you're going to distribute an oxygen to each one of the reactants. Again, not the chemically sound answer. Do not explain it that that's the way it was taught to you. This is a trick. This is cheating, kind of. So I'm going to write CO, and I'm going to write SO. And I'm going to ask myself, what is the most common form of carbon and oxygen I can think of? Hopefully you know carbon dioxide. That's a pretty common form. So I would take that. And then what is a common form of sulfur I could make? Some people say SO2, which is a perfectly fine answer, carbon or sulfur dioxide. You may even say sulfur trioxide. But if you were in baby chem last year, you may say, oh, sulfate, in which case you'd be wrong. How is a gas going to be burned and produce an aqueous solution? No. So don't go reaching too far. Think, I'm making a gas. What's a common form of a gas that contains sulfur? Let's say sulfur dioxide. Sulfur trioxide is also, I believe, an acceptable answer for this if you said SO3. It just makes your balancing a little more crazy. So I've got one sulfur, one sulfur. Sorry, one carbon, one carbon. I've got one sulfur, I've got two sulfurs. So let's balance out the sulfurs. Put a 2 here. Two sulfurs, all right. Carbon and sulfur balanced out. Last thing to do when balancing a combustion reaction is balance the oxygens. I've got 2, I've got 4, so I've got 6 oxygens on this side. 2 times 3 is 6. So that's my balancing reaction. What is the oxidizing agent for this reaction? So what is an oxidizing agent? It's something that is reduced. So what went down in charge? Oxidizing agent means it was reduced. So what was reduced? Well, in this case, oxygen goes from being oxygen 0 to oxygen 2 minus in both of these. So I would say oxygen is reduced. Oxygen is my oxidizing agent. And if you're playing the home version of this game, go ahead and do H, because it's a very similar process. Remember, the answer keys are on the next page, so don't get lost. But we're going to skip around again, and we're going to go to I. And by I mean K. All right, so K says excess concentrated sodium hydroxide solution is added to a solid aluminum hydroxide. So step 1, cross out nitrate. No nitrate. Circle any state of matter. State of matter right there. Cross out any group 1 metal if it is not already circled, and this is not, so I can cross through that. And then underline any halide, no halides. Look for burned in air, no burned in air. Look for excess concentrated. Oh, praise the Lord, there is excess concentrated. Oh yeah, more happy faces. And I'm not going to attempt to draw what excess concentrated looks like, but you get the idea. Good things. Now, excess concentrated means we are in the land of complex ions. Let me give you some information on complex ions. A complex ion, there's a lot of possible answers whenever you have a complex ion problem on the AP exam. So whenever you see excess concentrated, even if you feel like you came to the exam and ate an extra bowl of stupid, you can usually get some points for an excess concentrated for a complex ion problem if you just have an idea in your head. Anytime we have an excess concentrated solution and we're going to form a complex ion, and I have no idea what I was just talking about because the announcements came on and you got paused. So I'm just going to proceed as though I didn't know. So we're going to keep moving. Start by writing what's left like you normally would. So hydroxide solution, OH minus. Solid aluminum hydroxide. All right, our product, we're going to open a bracket. And inside that bracket, we're going to write the metal or the cation for whatever is still together. So the metal left over is aluminum. That's the metal I'm going to write. And I'm going to make a little note to myself in small pen ink or small pencil. That aluminum's charge is 3+. Whether it's aluminum or it's iron or it's something, note what the original charge was. So aluminum, 3+. Then put the anion that's in excess concentrate. What's in excess concentrate? Hydroxide. So I'm going to put hydroxide in parentheses. Now, you're going to take that charge of the metal and you're going to double it and put it down below. So 3 times 2 is 6. Okay. Now add up the charges here. So I have hydroxide, which is a -1. 6 times -1 is a -6. All right, and then the charge for this complex ion, since an ion has to have some sort of charge, the charge is the addition of those two. So 3 plus -6 is a -3. So this would be my complex ion. Just get rid of these little notes to yourself because they're not going to get you any points. They're not really supposed to be there. And there you go. Now this is not the most common complex ion. By no means is it the most common, but it is one possible answer. And therefore it will get you points. So this is the strategy I use for complex ions. Now when it comes to naming complex ions, the naming process of a complex ion is a pain in the butt, and I will attempt to teach it to you. If I teach you wrong, I am sorry, but I don't know it. I am basing my information off of what one of my most intelligent students from a couple of years ago told me. So if I get it wrong and you're offended, stop watching my videos. If you're in my class, get over it. It's going to be one of those points that you're just going to forfeit if it comes up and you don't know. So make up a name. Call it Susie for all I care. But from what I remember, from what I was told by a student, because I don't care enough to look it up myself, is that it's the prefix for however many of the anion there is. So in this case, it's hex, because 6 is hex. So this is hexa. Then the name of the anion, or the root of the anion, so this is hexahydroxyl. The Latin name of the metal, and then 8. So this would be hexahydroxyl aluminate, would be the name of this complex ion. Again, if I'm wrong, if I lead you astray, I'm sorry that I'm not sorry. All right, I realized I didn't balance my equation. So to balance these, it's actually fairly simple. Just look at your anion. I got 3 on this side, I have 6, so I'm going to need 3 more. And that will balance out the charge. And that is writing net ionic equations in a nutshell. Sorry it took 20 minutes.